Okay, so hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Tamil Selvan Murugesan, part of the data science team at Analytics Vidhya. For those who have joined us for the first time, a brief introduction about the DataHour. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain, and as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. So now on to our session today, which is MLOps, the practical implications going forward. In this data hour, Mr. Ruju will cover the impacting points about MLOps and then will demonstrate how to actually use FlAi MLOps Suite. I hope you are excited to attend the data hour with us. Before we kick things off and I hand it over to a speaker, a quick recap of housekeeping items. We are recording this session and the recording will be available on our YouTube channel. The link you can find the link in the description. Please use the Q&A section for asking any questions you might have during the session and we'll do our best to answer them as the data hour progresses towards the end. We'll be sharing a quick poll towards the end. You are all requested to kindly fill the poll before leaving the session. Now onto our session, onto our speaker. In this session of Data Hour, we have Mr. Ruju Alurkar with us. Mr. Ruju is the CEO of FlAI MLOps. He is a BTech graduate from VT, Indian Institute of Technology, and holds extensive experience in creating and deploying pipelines as an MLOps engineer, prior to starting off with the idea of FlAI. FlAI is an end-to-end low-code SaaS platform to design, create, build, and deploy AI pipelines at scale. So over to you, sir. The virtual stage is all yours.
Hello. Hello. Okay. All right. Shall I start?
Sure, sir. Sure, you are good to go.
All right. Perfect. So, welcome to the podcast, everyone. Today's topic is MLOps and the practical implications going forward. So, before I start off, a little bit of introduction about myself. This is me, and you can follow me and connect with me on LinkedIn. I also write Medium blogs from time to time. So I started my career a little bit early. I started in second year of college itself with a data science job, and I was doing consulting for foreign startups and even larger companies by the time I was in third and fourth year. And that's how I got to where I'm today, where in between my consulting and assignment
Sir,
of
hello, sir. Sorry to interrupt you. Sir, your voice is still a bit low. Audience, sir, just putting up the point. Can you please increase your microphone's volume or anything like that from your end?
very sorry. Let me just check. Huh?
Sure, sir.
Is it better now?
Uh,
I'll just
guys,
implement this meeting.
sure, sir.
Okay.
Sorry for the inconvenience, guys. The speaker will join shortly. He's trying to rejoin.
Hi, is it better now? I hope
Yes,
it's
sir,
much
it
better.
is much better now.
Okay, good, good. I had to change some settings. All right, so let me share my
Thank you, sir.
screen. Okay, one sec. All right, is it up?
Yes, sir.
Yeah. You can interrupt me anytime if the sound goes bad again. So, all right.
Sure, sir, sure.
So, a little bit about me. I started off working a proper job in third year. I started off with data science in second year of college itself, and that's what has brought me to where I am today because I started off early, and then I went into the roots of how to figure out what the core challenges is in AI and ML. And I understood that the core challenge was more so about the infrastructure and the deployment part than the model part. And companies or industry people were still much more focusing on the model part. So then I had an idea and I decided to build on top of that idea to solve that infrastructure problem. And we ended up with FlAi. So FlAi is a MLOps product company, and we have our own flagship platform, the FlAi MLOps Suite.
Sir, again, sorry to interrupt. The PPT from your screen sharing from your side is flickering, like it is blurry sometimes. It is not, the clarity is not good.
Mm, okay, one second.
Yes.
Yeah. Hello.
Hello, sir.
Yes, I'm back. So
Yes, sir.
One sec. Is the screen up?
Yes, sir. Now it is much better.
Okay. So, hi. This will be my second introduction, and thanks to the internet connection. So, I am Ruju Alurkar. I am the CEO of FlAi MLOps. It's called FlAi, and here are my LinkedIn and Medium links. I do occasionally write blogs. So the way I started off in AI/ML was I started pretty early, and I got into it pretty deep. So by my final year, I was doing projects on Kubernetes where we had pipeline level deployments directly on Kubernetes based on Scratch. I mean, by Scratch pipeline deployments. And that's how I got the idea for my product to automate the infra side of the problem of AI/ML. And that's what culminated into FlAi. So feel free to follow FlAi's LinkedIn page or write to us on demo@flyamlops.com. Now, starting off with the topic of the day, I want you all, I'm going to keep this picture on the screen and I want you all to focus for 1 sec and think about it. This is a picture of what could be possibly the future. How does the landscape of tech, of cyber look like 10 years from now, 5 years from now? We'll have drones flying around. I mean, that's what I'm stating the obvious. We'll have autonomous drones, we'll have autonomous planes, we already have cars that are driving themselves. We'll have AI taking key decisions in the industry sphere. We'll have AI taking key decisions in the medical sphere, where the basic diagnosis is done by AI, and the later stage or the more critical stages are then attended to by doctors. We'll have AI in sports. We'll have AI in, we already have AI in marketing. So this wide scale deployment of AI has been talked about a lot, and it was previously also talked about a lot 5 years before. But today we see that only like 10% or 20% of it is actually in reality. We barely have natural language processing algorithms that can translate from one language to another or understand the words of what you are speaking, but then they go bad or they go wrong when you change your accent just a little bit. We have AI which can say detect objects in your camera, but it goes wrong a lot of the times. The virtual background, which I was not able to put up today, is also AI. And virtual backgrounds are made up of different kind of image processing algorithms, and you might have experienced that they go wrong a lot of the times bringing in items from the background. So it's little things here and there just like that, where you can see that AI is in its infancy stage in the real world deployment. Larger companies, the FANG companies, or what today is called as MANG, they do have pretty good, or rather I would say really good levels of AI deployed. But when it comes to the lower rung, or when it comes to the layperson, the percentage of AI that is he is getting in contact with on a day-to-day basis is hardly like 10%. And that is what will change tremendously in the coming 10 years. So when we look at change, we are at a cusp point in the history of technology where Industry 4.0 has just finished and Industry 5.0 is starting. I'll explain it a little bit in detail in the upcoming slides, but I want to go first to a case study about touchscreens. So everybody, I assume, knows very well about touchscreen technology.
Sir, sorry to interrupt. Can you try changing the settings of your volume, like previously what you had? Like the PPT is clear now. Once you rejoined, again the audio went low. The audience, sir.
Hello.
Yes, sir.
Uh, Now, is it audible? Hello.
Sir, yes, sir.
Okay.
Sir, can you hear me?
I can hear you perfect.
Yes, sir. Yes, sir. We can hear you, sir.
All right. Should I continue?
Yes, sir. Please continue, sir.
Okay.
Sorry for the inconvenience.
Uh,
Please continue, sir.
okay. No problem. I don't know what the issue seems to be. All right. So, recapping, um, when we look at a transformational change in technology, say when the internet came on in the 2000s, or when computers themselves came on in a big way in the 70s and 80s, you have to look at what kind of technologies were there at that time already, on the top of which that technology was upgraded or built. So let's look at the case study of touchscreens. Everybody has a touchscreen phone today. There'll be nobody in the audience who does not use a touchscreen phone. How did this transformational change come along? So the first touchscreen, believe it or not, was uh, in place more than 60 years ago, and that was a capacitive touchscreen. The touchscreens that we use today are, most of them are resistive touchscreens, and that came along in the 1970s. The first commercial product with a touchscreen was the HP 150 with a kind of resistive touchscreen which you could control. Yet, for almost 20 years, or 20, 25 years, the touchscreen technology came up and then it died down. And why did it die down? The first popular touchscreen hardware thing was the iPhone. Before the iPhone, there was no gadgetry or piece of technology, whether it be a computer, whether it be a phone, which was touchscreen and which was widely popular and adopted by a lot of people. So why did the iPhone become popular? And it all breaks down, or it all boils down to what kind of other technologies did touchscreen need to be successful by itself. So it needed the phone to have an excellent battery, it needed to have an excellent display, it needed to have all those softwares in place which would enable the application experience behind the touchscreen, and it needed to have sufficient RAM and processing power, because that is how the touchscreen experience in all became fluid. When we look at MLOps, the same thing we can see happening today. MLOps, or AI ML, to become widely used, needs basically five things that are the pillars on which it is built on. The first one is data collection and storage, where you need massive capacity of collecting, storing, and indexing the data and being able to access it very fast. The second one is networks. So just a couple of days before 5G was launched in India, and 5G is supposed to have speeds in Gbps and not Mbps, and that will bring a transformational change where from the data store the data can travel much faster to your device. So your device does not have to be very strong in itself in terms of computing power, or it can actually take on and do functionalities which were not intended to be done on that device. Another continuation of what I just said is cloud computing, where most of the processing happens on cloud, and only the end results are conveyed back to you via API. So in this kind of cloud processing, data and networks jumble, you add another thing which is called the edge devices or the IoT devices, where each device has a small microprocessor. Everything, all the data is then collected and stored to a third place. Everything is interconnected via very fast networks. And finally, in using cloud and the power of cloud, you can process much bigger, much larger uh, things. And when you add AI ML in the mix, that is where MLOps comes into the picture. MLOps is the glue that is binding all of these five things together, which I try to explain in as simple terminologies as possible, which will make AI take off in a big manner, where you'll use AI on your phone on a daily basis. You'll use AI, or you will gel with AI. A similar or a very simple example would be the way today the metaverse is taking on, where you have to wear those goggles. Similarly, you will have devices, say something like a Google Specs or a Visor, where AI will project different information to you, just the way it's shown in movies, while you are going, while you are running, while you are going someplace. And you can take decisions on the fly based on that. In technical terminologies, the last four industrial revolutions happened exponentially, building on top of each other, and happened at for a much faster rate than the last one. So if the first industrial revolution took 100 years, then the next one took lesser, the next one took even lesser, and the 5.0 revolution, where everything will be embedded computers with AI assistance, will go even faster. In technical terminologies, this is what is the cusp point. We are at a cusp point where MLOps will enable the interconnection of all of these technologies, which you are seeing on the screen, and using AI into it. It will be a powerful and something so splendid which you might not, which might have implications that you have never imagined before. So that brings us to the question that AI has been around for around 5-6 years in a big way. It's been popular, the Python processing libraries, this, that, they've all been there in place for at least the last 5-6 years. So, what is the challenge when we go from doing AI in what is called as experimental conditions, where you extract a small set of the data, process it, and get the results, and then get the predictions, and so on and so forth, to doing it in real life? And the mass or the scale of processing is what is different. So let me start with going back to a little bit of the basics, where your traditional program looks somewhat like this. You've got the data incoming, you've got the rules that are coded in by a programmer, by human being, and you've got the output, which is pretty simple. In machine learning, this is how it goes. And this small change in this process at the beginning, where you put in data and the set of outputs that you have, and the ML program actually learns the rules, is what causes the disruption when it comes to employing things at scale. In DevOps, for example, you could develop a website very nicely, and you can deploy it at scale. So in dev, if it is catering to 10 users, in the deployment phase, it can easily cater to 200 users without any significant changes in the application. And that is because at each stage, when you add on these traditional program blocks, you are going to get something that is still pretty much in a set pieces of configurations. So let me go back to the last slide a little bit. So this is your machine learning program, where it will output the rules itself, and those set of rules is what is called your AI/ML model. Now your AI/ML model takes the new data and it applies the rules again, and it keeps on giving the predictions. And that is how AI/ML models work. Now MLOps is this, where you have large scale data, multiple AI ML models, multiple predictions, probably multi-stage predictions, where stage one of models is feeding to stage two and stage two, so on and so forth, and then the final prediction. And this is where, because in a traditional program, at each stage, stage one, stage two, stage three, you know the set of combinations, you know the set of rules, and the rules and the outputs are fixed, whereas in AIML the rules and the outputs are not fixed. So you don't know the end number of permutations and combinations that might come out from the start of your program to the end. So that is where the unpredictability in deploying AI at scale comes into, and this is where MLOps has big issues in deployment. So some of the current issues are, there's a high model failure rate. So some test case studies say it's 70%, others say it's 85%. Whatever it is, it's definitely not a desirable success rate where data scientists are working um, in the experimental conditions. They're developing the algorithms, they're developing the models. The models are working perfectly in testing conditions, but when you go to the production deployment, they are failing miserably. The second thing is because I'm sorry, because the scale and scope of 1 second, let me just grab some water. So because the scale and scope of the projects in DevOps is always, whatever you do in dev, if you replicate the same thing in production, then you get pretty much the same kind of results. But in MLOps and AIML, it's not like that. So the tools that were used for the dev environments, say your Jupyter notebook or something like VS Code, the same thing cannot be used as it is as a tool in MLOps deployments. A third big problem is when you go for large scale MLOps deployments, you need you need replication at the infrastructure level. You need modularity and kind of Lego blocks, which you can build a Lego block and then plug and play it anywhere else. And that is how you save time for the next iteration. This capability does not at all exist, uh, at least pertaining to AI ML platforms. The last part is that there are so many platforms in the MLOps ecosystem or space that users have to often juggle in between a lot of them. So I've also been a part of this problem because I've had to juggle through multiple platforms, do cross-platform integrations, work the issues between two different platforms, when that should not be the need to do so. All of this in the end affects your time and cost to a production grade machine learning deployment, ML pipeline deployment at scale, if there is one. So I'd like to introduce you to the FlAi MLOps Suite. FlAi is an end-to-end drag and drop SaaS platform for creating and deploying machine learning pipelines directly to Kubernetes. Okay. Just let me know if there's an issue with the video that I'll be playing. So here's a small glimpse into FlAi. This is a recording of FlAi in action. All right. So that's a short glimpse into one of our demo pipelines on the FlAi MLOps Suite, our end-to-end SaaS platform for MLOps. And the way we envision it is that data scientists should have to focus only on the Python code, only on the AI/ML code, and they should not have to worry about the DevOps deployments when it comes to deploying a large scale pipeline, a heavy pipeline. But they should be able to focus on their basic Python code, their machine learning skill set, and the rest of the process, the provisioning of cloud resources, optimization of cloud costs, uh, the auto deployment of certain resources. Everything will be automated by FlAi. That will allow different entities, different companies, different individuals, different coders, data scientists to build bigger and bigger and bigger AI/ML pipelines to eventually create what we look at, or what I pictured, what I showed you in that picture as the future of the next 10 years. So that is all. I'd like to take some questions now. Uh, yes, Bharat Kumar. Hello. Okay, the first question I see is Nabil, and the different stages of prediction are: first, it is data extraction, which is traditionally called as ETL. Uh, the second stage is data cleaning, where your data is never in a set format. It might come to you, in different formats, even in different file formats, different encodings. You have to clean it and get it in one set format. The next stage is your pre-processing stage. So I'll just go back to my PPT thing and I'll show you. So the pre-processing stage has operations like scaling different columns, or eliminating different columns, or hello. Yeah. So scaling different columns, eliminating different columns, getting say pivot columns out of the data, so on and so forth. That is what the pre-processing stage is. And one second. The last stage is actually, as part of the pre-processing stage, is encoding. So that might include label encoding, one hot encoding, so on and so forth, so that the data gets in the exact format that needs to be fed into your model. And then you have the AI/ML model, which you train on a training data set, do the train test split, train it on the training data set, test it on the testing data set, and then if your client so requires, they'll have a data set in the blind, which is called as the uh, deployment data set, which which is fed to your model, where they test your model, how accurate and how good it has been made. So Suresh, the data input cleaning does not happen automatically on FlAi, uh, because there is no set way to have all of the data cleaning functionalities kind of jumbled into or scrambled into one platform. So that's not optimal. So we suggest that data scientists do the data cleaning on FlAi itself using their own Python code. Okay, so Bala Subramaniam. Uh, the question is, what is your thought on getting high-end compute in GPUs? One of the major problems in deep learning projects. So that is one of the major problems that FlAi automates. Uh, I'd like to show you one slide. Let me see if I can pull it up. So this is one of our very high-end demo pipelines which we built for a prospective client. And the function of this pipeline is to entirely, it takes the input of 3 lakh data input samples, and it predicts the loan approval ratings for it trains 4 different models to predict loan approvals for future incoming customers. Now this pipeline uses heavy so it has got one neural network model, one XGBoost model, and 2 clustering models. So it uses a pretty heavy workload, and GPUs are especially needed for the neural network and the KNN clustering algorithm. So what FlAi does is it completely automates. This is how we sync with Kubernetes clusters in your cloud, and it completely automates the provisioning of GPUs to your pipeline, so as to say. So that is how the GPUs are auto provisioned within FlAi. Okay. So one question is how to integrate our data pre-processing and pre-existing models into your tool. So with FlAi, you have the capability to import certain Python codes and pipelines directly. So just bear with me for a minute, and I'm going to actually take you to a demo of our platform. Okay, just can somebody answer in the chat if my screen is visible now?
Screen is visible, sir.
Yes. Okay. Perfect. So, one second. I'm sorry. All right. So, this is the pipeline that I was talking about. Now, this one takes 1.5 hours to run, even with GPUs. It's a pretty heavy pipeline. I'm not going to run that. What I'm going to do is open another pipeline, uh, which I can run while I answer a couple of the questions, and you will also get to see it live in action. So let me tell you a little bit about this pipeline. This pipeline is a road quality prediction pipeline. So basically, it takes the gyroscope data from the two suspensions of a car, and when that car is going on, say, 20-kilometer road, and in the end, it gives out a clustering model plus a neural network LSTM model that predicts the quality of the road that that car has driven on without knowing that historical data, without knowing the actual data. So let me give the run for this pipeline. Uh, and I'm now going to open a new pipeline to show how you can import uh, existing uh, models and code blocks. So basically, we have developed the functionality to import Python files directly into your system. So you can directly upload .py files. Let me just share my full screen here. Okay, so you click on import.py, then you get some Python files, and well, there you have them. So you can import your Python files directly as they were from your system, and you similarly can import an entire Jupyter notebook, or we have developed a special protocol, which is the .fly protocol, using which we can say export and import. So I'm just going to go to this pipeline, suppose, and I've already built an entire block, which is to say the code inside the container definition, which is this, and the entire input output files configuration. And I can just click on export block, and that block is downloaded as a .fly file. I can also select like multiple blocks. Say I want to export all of these 5 blocks, export them, and they'll be downloaded as a zip file, and I can import them directly into here. So I'm just going to do a little bit of cleanup. I'm going to delete this, and I'm going to import blocks. So I'm going to import multiple blocks here. And there they are. So these are blocks. The LSTM write is the exact block as it was in the previous pipeline, or the pre-processing as it was in the previous pipeline, and you get it entirely with the full configuration, with the code in it, and the configuration setup, all of it ready made. Now you just have to connect it with, say, other blocks, configure the files, and you're good to go. So that is how we manage importing existing applications or things into FlAi. So another one of the question is time saving comparison statistics. So the empirical studies that we have done. So let me actually give you the answer based on the pipeline on my screen, the loan approval prediction pipeline. This pipeline does not run on a single instance, single compute instance deployed Azure ML notebook. It does not run on Google Colab deployed with GPUs, but on FlAi it can run around in 1.5 hours. So that is the power of what we use under the hood, Kubernetes architecture, mated with some of our optimization stuff, because of which the time reduction that we have estimated is around 3 to 4 times with comparable costing platforms or comparable costing cloud infrastructure. So that is the kind of time saving and time saving plus cost saving done in that order. So how can university students learn this platform? Do you have any training program? So we don't have a training program as yet right now. We would be happy to collaborate with university to design it and we do have a rich uh, demo pipelines catalog. So I just showed you two pipelines out of that. We have around six which are different pipelines for different sectors, and we also have excellent documentation which will be provided along with our platform. So it's FlAi is almost intuitive. So in my team we have got some interns who could pick up the usage of this platform as long as they knew their data science AIML basics. They could pick up the usage of this platform in less than a week. All right. Uh, can we compare this with Azure ML pipelines? Bhavesh Wadhwani. Okay, so yes, Bhavesh, we can compare this with Azure ML pipelines. So FlAi is a no code or a low code solution, whereas in Azure ML you have to spend or invest, I would say, significant amount of time and resources to actually get into using that platform effectively. Whereas with FlAi, you don't have to put in any time or efforts to learn MLOps per se, and you can get started with a basic data science experience, and the MLOps is completely automated. Any resources to start for MLOps for beginners? Um, I would So I would suggest I never learned from any particular book or any resources. I learned on the go. So I'd suggest start get into a good company, get into a good internship where you are given the chance to explore MLOps. You are given the chance and access to Kubernetes, cloud platforms, etc. And that is how you can start, because there are very few courses on MLOps as say which do the job perfectly. Does this handle cross functional function? I think okay. Anonymous attendee. Okay, does this handle cross platform functioning? Is that what you mean? So cross platform functioning is something that we customize for clients. We don't do it unless it is required. So currently, FlAi integrates with certain platforms as per the requirement of our current clients. And if your requirement or if the need for that requirement is sufficient, we can add that functionality into our next version of FlAi itself. So that way we are We're not open source, but we are open suggestion platform. All right. Ajit R. I am currently learning ML algorithms and I don't know anything about MLOps. So Ajit, I think that MLOps is one step above ML algorithms. So you should at least understand the different ML algorithms first and different kinds of applications, not just understanding the algorithms in theory, but you should have applied it for at least 6 to 8 months or a year before you can get into MLOps effectively. Because MLOps is, you have to understand your basic ML for it. All right, last question. All right, Nabil. FlAi essentially does all of this to final form of data, which can then fed to the ML model. So FlAi is not, and I'd emphasize this again and again. We don't want our customers and our users basically to be restricted in any form of usage, which often happens with a lot of no code or low code solutions. Hence, we have completely uh, automated the MLOps part where you don't need to do the MLOps, you don't need to provision any kind of cloud infrastructure, you don't need to install anything additionally. It's a complete SaaS platform, and you can get started on the go. Your pipeline will be auto engineered. I mean, it will automatically pull GPUs, CPUs, and everything if needed. But we don't want to emphatically interfere into the AI/ML code, into the Python code of the data scientist. We want to make work easier for them where they are not experts. Where they are experts, well, let them do their work. All right, Bhavesh. Thank you, Bhavesh. Uh, okay, I've got a funny question here. If these platforms automate all the processes, where do you see the need of humans in the ML space? Well, uh, at least for the next 20 years, that's not going to happen. For the next 10 years, it's definitely not going to happen. So it's a fun question. Uh, and regarding the next question, you can please contact us through our website. Uh, uh, you, I'll just put up the website slide here. So please contact us through our website, and my team will get back to you soon. Are there any more questions? Okay. How do you incorporate feature engineerings in the pipelines via your platform? So we do not incorporate feature engineering. Feature engineering can be easily done via using pandas and other libraries already existent in Python, and that is not something that needs MLOps to do. Okay, for Alteryx, which format is required into FlAi? I'll have to check on this. One sec. So currently, we don't directly connect with Alteryx ETL tool, but you can offload the Alteryx data into CSV format, store it in your cloud storage bucket, whichever it is, AWS, GCP, or Azure, and you can pick up the data files from there. All right, thank you, Martin. So, do we have any plans to incorporate some modules which will help users do better feature engineering? Yes, definitely. So, with feature engineering, there is no one answer fits all. That is what our design. So, during our design phase, we had given a thought to feature engineering extensively. And the problem with feature engineering is there is no uniform set of uh, uh, say feature engineering functions. There are some that are used commonly, but then there are lots that are not used that commonly or not used in the same fashion, and those are very difficult to integrate into a, UI based platform. So that is where we leave it to the data scientist. We say do your pandas thing, do your I don't know, numpy thing, and that is we can include feature engineering if it becomes a pressing demand for, or say a pressing suggestion from many of our uh, clients. So, all right, are there any more questions? I think that is all.
Uh, Yes, sir. Hello, sir.
Yes.
Thanks
So,
a lot, sir.
thank you too. Sorry from my side for the speed or whatever issues there were, audio
It's
issues.
fine, sir. It's worth it. Like whatever it is worth it. Like I can see from the chat section that audience had absolutely loved the session.
Okay, great. So it was fun to demo FlAi. I hope that we can again demo, say, one of our POC or one of our demo pipelines on your platform. Thanks a lot for hosting me.
Sure,
And
sir. Sure, sir.
yes,
Thanks a lot, sir. And also on behalf of Analytics Vidya and on behalf of our audience, we thank you a lot for your time. Hopefully, we can conduct more such sessions in the future, sir.
all right. Okay.
Yes.
So,
So also, I would request everyone of the audience to participate in the feedback poll. Also, I have shared the upcoming webinar links, which you might be interested in. There is a session at 8:30 today. I have shared the link in the chat section. Please check it, guys. You might be interested in that as well. So yes, thanks a lot, sir, and thank you, guys. Hope the session was useful to you. Sir, anything you want to share, sir?
no, thank you for hosting me. Apart from the technical delays, I also enjoyed presenting the concept, and we really hope that as the audience gets more and more knowledgeable about MLOps per se, we can have more people participating into um, into MLOps, into building bigger and bigger pipelines, and we'll be starting free trials on FlAi somewhere around the third week of October. So follow our LinkedIn page and stay tuned for the news. We'll announce it on our LinkedIn page. All right, guys. It was nice. It was nice conducting this session. Thank you all for coming, and have a nice day. Bye
Yeah,
bye.
sir. Thank you, sir. Thank you, guys. Thanks, everyone. Yeah.